Hello guys, welcome to my YouTube channel. That is Mwalimu Omar Saadibule. So in this video, we will look at quantum numbers. Generally, there are four quantum numbers. That is a principal quantum number, which is denoted by letter N, azimuthal quantum number, which is denoted by letter L, and magnetic quantum number, ML, and the spin quantum number, which is denoted by letter MS. So these four quantum number, generally, they give the address of the electrons. The address of the electrons, or in other words, where the electrons are likely to be found, where the electrons are likely to be found. They give the address of the electrons, or where they are possibly found. So let's see the first principal quantum number. The first quantum number, that is a principal quantum number. Principal quantum number N. So principal quantum number gives the size of the orbital. It gives the size of the orbital, the size of orbitals, or in other words, it represents the energy level. It represents the energy level or the shell, the energy level or the shell. So principal quantum number can have any positive integers that is equal to 1 or greater than 1. That means N can be 1, can be 2, can be 3, can be 4, can be 5, and so on and so forth. So the principal quantum number cannot have a negative value or with no value, or be equal to 0. With no value, cannot have negative value, or be equal to 0, because it is not possible for atoms to have a negative value. It's not possible for atoms to have negative value, or with no value. So N is any number that is equal to 1 or greater than 1. So that means N can be 1, can be 2, 3, 4, 5, 6, and the list is endless. So the value of N denotes the orbitals with the lowest energy level. The value of N denotes the orbital with the lowest energy, or what you call the ground state. Ground state. So that is the principal quantum number. So it can have any value that is equal to 1 or greater than 1. So let's look at the next one, that is the azimuthal quantum number. Azimuthal quantum number, or what we call the angular momentum quantum number, which is represented by letter L, So the azimuthal quantum number represent, or it gives the shape of the orbitals. It gives the shape of the orbitals. The shape of the orbitals I will give you in another video. So the azimuthal quantum numbers gives the shape of the orbitals. It depends the number of principal quantum number. The value of azimuthal quantum number depends the principal quantum number. So the azimuthal quantum number can have any value, can have any value that is, can have any value from zero to all the way n minus 1. So the azimuthal quantum number can have any value from 0 to all the way n minus 1. So that means it depends the principal quantum number. For instance, if n, the value of n is equal to 3, the azimuthal quantum number will be will have a value from 0, that is, L will have from 0 to n minus 1, which is now 3 minus 1, which is 3 minus 1 is 2. So L can have 0, 1, and 2. You understand? If n is 3, L will have any number from 0 to n minus 1, that is 3 minus 1. So the value of azimuthal quantum number will be 0, 1, and 2. If n is 4, if n is equal to 4, that means L will be a value from 0 to n minus 1, which is now n minus 1, our n here is 4 minus 1, that is 3. So the value of L will be 0, 1, 2, and 3. So L will have a value of 0, 1, 2, and 3. So the value of azimuthal quantum number depends the value of the principal quantum number, the value of principal quantum number. For instance, let's say another one. If n is 5, if n is 5, L, or the azimuthal quantum number, will be from 0 to 5 minus 1. That means L will have 5 minus 1 is 4. L will have values from 0, 1, 2, 3, and 4. And that is a azimuthal quantum number, or the angular momentum number. So let's see next magnetic quantum number, ml. The magnetic quantum number, ml, that is the fourth, the third quantum number. The third quantum number, that is magnetic quantum number. Represented by ml, magnetic quantum number represented by ml. So the magnetic quantum number represents the total number of orbitals. It gives the total number of orbitals. number of orbitals, or the orientation of orbitals. That is whether the orbitals lies in the x-axis or the y-axis or z-axis. So magnetic quantum number can have any values from negative L to all the way positive L. From negative L to all the way positive L. For instance, if azimuthal quantum number, that's L, is 3, the magnetic quantum number will be negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3. So ML will range from negative L to all the way positive L. That means if L is 3, ML now will be negative 3, negative 2, negative 1, 0, 1, 2, and 3. If L is, let's say, 2, our ML will be negative 2, negative 1, 0, 1, and 2. You see, if L is equal to 4, ML, or that is magnetic quantum number, will be negative 4, negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3, and positive 4. So that means the magnetic quantum number depends the azimuthal quantum number. So it ranges from negative L to all the way positive L. If L is 3, the ML will be negative 3 to positive 3. If L is 2, ML will be from negative 2 to positive 2. If L is 4, ML will be negative 4 from negative 4 to positive 4. So that is a magnetic quantum number. And lastly, we will look at the spin quantum number. The spin quantum number, that is spin quantum number. So the spin quantum number does not depend any of the three quantum numbers. It does not depend the magnetic quantum number, it does not depend the azimuthal quantum number, or it does not depend the principal quantum number. That is, it is independent of the other three quantum numbers. So spin quantum number gives the direction, it gives the direction in which electrons are spinning. Electrons are spinning. So the spin quantum number of electrons can either be positive 2 by positive half or a negative half. Positive half, that is the clockwise direction, or what you call the spin up. And negative half is the anti-clockwise, or what we call spin down. So spin quantum number gives the direction in which electrons are spinning. So electrons are either spinning clockwise or anti-clockwise. That means the electrons will look like this. So one is spinning up the other one is spinning down. So that is a spin quantum number. So in summary, if the value of n is 2, or let's start from 1. The value of n is 1, the value of n is 1, L we say is value from 0 to n minus 1. So that means if n is 1, 1 minus 1 is 0, so L will also be 0. ML obviously will also be 0. If n is 2, L will be values from 0 to n minus 1, that is 2 minus 1. 2 minus 1 will be 1. Okay, L will be now 0 and 1. And ML will be negative. ML, we say it is all the way from negative L to positive L. So our L here is 1, so we'll have negative 1, 0, and positive 1. So if n is 3, L will be n 3 minus 1, that is 2. So L will be 0, 1, and 2. ML will be negative 2, negative 1, 0, positive 1, and positive 2. If n is, let's say, 4, L is equal to n minus 1. 4 minus 1, that is 3. So L will be 0, 1, 2, and 3. ML will be all the way from negative L to positive L. L here is 3, so negative 3, negative 2, negative 1, 0, positive 1, positive 2, and positive 3. And lastly, if n is 1, let's see the last one. If n is equal to 5, L is equal to n minus 1. It will be 0 from 0 to L minus 1. So 5 minus 1 is 4. So L will be 0, 1, 2, 3, and 4. ML will be all the way from negative L to positive L. So our L here is 4. So negative 4, negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3, and positive 4. So that is the summary of the quantum numbers. Welcome to my channel. For you to get more videos, you can subscribe my YouTube channel, that is Mwalimu Omar Saad. Thank you.